it with others. Hey, Rael. Rael 11 is here with us, and thankfully for him, he does not look like me in my green shirt in real life. So welcome to our webinar on foundations. And as I've been thinking about this, first of all, we are concluding our series. We've broken the house down into all the different parts and gone and taken a deep dive into each of them. This is the last of the series. If you missed any of them, reply to the email that you'll get from here, because we will send you the recording of it, and you can play it for fun. Maybe pop some popcorn and show it to your family. I'm sure they'd be fascinated by it. Or if you want to take a deeper dive and get some CE credit, Rael has an amazing class, Anatomy of a House, that he will be teaching July 15th. So those are your options in terms of getting more information. But today you're here, let's take a deep dive into the foundation. And one of the things that I was thinking about is how important the foundation is. Like, if you just look at whatever chair you're sitting on right now, the reason it's able to sit on the floor wherever you are relates back to the foundation on some level. There is something supporting you and your weight, and that goes all the way back to the foundation. It's one of the most critical parts of the house. And I would offer you this. I would offer you that Home Probe can also be a foundational member of your team, and we can support you behind the scenes and hold your weight through the inspection process, even sometimes when you're not watching us actively do it. So with that, I'm going to turn it over to Rael. If you have questions, Rael is the perfect person to ask them of, because he has been doing this forever. But really, he was a GC for over 25 years. He was one of our lead inspectors for more than 10, and I just think there's nothing Rael hasn't seen. So so put your questions in the chat or in the Q&A. If they go in the Q&A, they stay anonymous. If they go in the chat, everyone can see them. We will take them all at the end. So if all you came here to get was pictures from Rael, you got it. And if you want to stay after and ask him questions about foundation or really any part of the house, he's game. So with that, Rael, take us away.
Okay, good morning, everybody. I'm going to share the screen right here so we can get into the bottom line of what we're dealing with here with our foundations. So, okay. So, think back to the days of the settlers when we had log cabins and there were no foundations, but the inside of the home was actually on the dirt. And in today's structural buildings that we do, especially for our single family homes, with the cost of land, it's pretty much broken down now into a slab or a basement. So the folks would dig out a basement. We're not really seeing too many crawl spaces anymore that we used to see in the early days. So slab, of course, and again, things have changed over the years. So the way it worked was back in the early days when we first started seeing the crawl spaces. Why were they there? Well, when the actual floor system was being elevated, and we wanted to heat our homes, we used to have floor furnaces, and those floor furnaces were installed in the floor in a hallway, perhaps, sometimes in a bedroom, but it just kind of was there, and they needed the actual body of that heating system to drop down below the floor. So the floor system was elevated on some kind of a pier. It could be brick, it could be wood, it could be bricks with cement block. No really poured concrete at that point because you didn't have the capacity to have a cement mixer location and then bring it in the truck and pour it like we do today. Everything was actually made by hand. So I remember back in the day when in the 70s when we were doing construction, we would have a cement mixer, a gasoline powered cement mixer, and you'd put in your gravel and you put in your sand and you'd put in your cement and mix it all up with the water, and then you would take it and pour it. Sometimes if it was a smaller need for an addition, perhaps, they would really just mix it up in a wheelbarrow. It was a time-consuming process and not exactly accurate, but that's the way they did it. So the minimum back in the 70s and things, we're dealing with a slab that would be 2,500 particles per square inch PSI. And over the years, it's changed up now. Now you can get 3,000 PSI and even as high as 4,000 PSI. And obviously the PSI is referring to the particles of cement that are put into the mixture to do our foundations and our slabs. In the driveways now, pretty much folks are going with the highest PSI that they can get, because we know that over time the cement does deteriorate and they do crack with expansion, contraction, and of course the weight over the actual surfaces. So here we're looking at a concrete slab foundation, and you see it's poured. It's about 6 inches thick. Prior to actually pouring the concrete, we would have had gravel and hopefully a plastic barrier put down in there to stop any of the moisture from the dirt from coming up through the concrete. It does actually, it's not a totally sealed unit, so in actual fact, moisture could come through. So we put down that moisture barrier. On top of the gravel, we usually would have some wire or some rebar in there to give it some extra strength and support. And of course, before we even poured it, we would have to have all of our plumbing waste lines, the PVC waste lines, the water lines, etc., would all have to be set prior to the pouring of the actual slab itself. So in this presentation, we are actually going to have a look at not just the different types of foundations, but what we actually see that happens to them over time. So some of the defective things that happen, but we also have to bear in mind, just as Melanie mentioned at the beginning of the introduction, is that this is the most important part of the actual construction process, because all of the structure that's going to be built in the home is going to be resting on this actual foundation itself. So the structure in the floor system and the walls and the roof, all of them has to be transferred to the exterior walls and to the interior walls wherever there is support on the very bottom level. So let's have a look at some of these things as we go. We're dealing next up, which was most common from about the 60s or late 50s on through even to present day. We deal with the masonry block, and the masonry block is a process that's is great. It's a super good way to put in a foundation, but with all types of foundations, we need to have the correct installation of the items around it. All right, so what we can see actually here on the left-hand side of this particular foundation, we can see some stains right here. And what we're dealing with is, because it is masonry block, the fact is that masonry block is porous. It's not entirely waterproof. However, what we can do is, when we're at this particular section of construction, we can come in and put in a foundation coating, which is like almost like a thick paint. It's an oil-based product, and it's rolled on or sprayed on to the foundation on the exterior when we are in this location and this time of the actual building. What's also a good idea is to perhaps have a drainage system installed here with some gravel and some piping. If you look carefully, you can see on the left-hand side here that we are actually below grade. The house next door is up here, and here we're looking at the dirt. So our foundation is actually in the dirt. So it would be a great idea here to actually have our foundation plastic and coating installed here prior to pushing the dirt back and tamping it on down as we continue with the construction. There are some openings, as you can see here. So the dirt that we're seeing is actually piled on high because it was dug out in order to put the foundation into place. These will probably be windows that will be installed into a future basement area. So, this is what we're looking at. You can see these little spikes that are sticking up here. They're actually are metal insertions that are put into the foundation. There actually do have, an area where we can put down a washer and a nut on top. Over here, you can see we actually have our bottom plate, which is a piece of 2x8 lumber, usually pressure treated, and where these protrusions come through, we put the wood on top of that, and then we can bolt it down to the structure. This is a process that's been around now for maybe 15, 20 years as a requirement to stop any kind of lift that might happen if there are some inclement weather with very high winds. Just an extra process in trying to hold the whole structure together. But just to jump back to this for a second, what will happen here is when the structure is built, one of the least expensive things that folks can do when they do build a home is to extend the downspouts from the gutters at least 6 feet away from the home. And there's a reason for that, is because as the water comes off the roof, goes down the downspouts, and it just dumps out all the water right next to the foundation, we do start to see some settlement in the corners, because the water is actually going down deep, and it's washing away some of the soil and some of the foundation cement that's in the bottom there. And so we start to see what we call a stair-step crack. And we can, sometimes pick that up on the outside of the home, where we would see it in the brickwork. And that would just be really more of a cosmetic thing, perhaps, until we actually got into the basement or into the crawl space, where we would see a settling going on. And it could be a simple remedy situation where perhaps we could extend those downspouts away to stop that water from constantly going to that particular location and allowing the settlement to happen. But what happens is, as it gets worse, and we call that movement and that settling, when we're dealing with it on a basis where it's all along the wall, the pressure that's put on that wall is called hydrostatic pressure. It's actually the wall is actually moving now, as you can see here. Look at the displacement that we see right here on the cement block. If you look over here on the left side, this is the moisture that's actually showing up at this corner, and that is a typical result of water coming out the downspout at the corner of the home and spilling down and going down into the dirt. And we could be 8 or 10 feet below grade here, and we'd be seeing all this moisture. The fact is that these masonry blocks are porous, but they also have 2 holes in the top, and so any moisture that comes in near the top here basically drains down to the bottom. So what we're seeing here is we're seeing that all along this wall we are having some movement, and this would need to be addressed pretty soon. If you're showing a home and you see something like this, not necessarily a crawl space, because I only actually met one real estate agent. She was really tiny, and she insisted on getting into the crawl spaces with me. But most real estate agents are not going to go crawling into a crawl space. So you would not see this until we get to the inspection process. However, if on the exterior of the home and you're looking at the brickwork and you do see some significant settling and gaps, both horizontal and stair step, then you'd want to probably talk to, when you call for your inspection, give us a chat and let's see if we can perhaps, you could send us some pictures. And maybe we would even recommend that before we do an inspection, you may want to get a structural engineer in there to have a look at this, simply because the structural engineer will give a scope of work, which will give the contractor an idea of what has to be done in order to remedy this particular type of situation. So you can see here another picture. Now we're getting down the wall a little further, but you can see it's pretty significant, the movement in that masonry block. I've actually seen some where they've tilted in so far that somebody had tried to remedy it by putting in steel girders on the interior of the wall, but there was literally so much water coming in through there that it was causing the actual foundation to fail, and that was not a good idea to continue on to purchase. All right, so again, we're looking at a inside of a foundation shed. If you look on the left side, we can see where we have our masonry block. And So what's happened in this particular case is an area in this foundation or footing area in the space where you can see there's a plastic barrier here, a vapor barrier that's in, but in actual fact, they've constructed and poured concrete on inside of the actual original foundation, again, in an effort to stop water intrusion into the basement. And again, the hydrostatic pressure is causing this retaining wall to fail. So even though the concrete is 4 to 6 inches thick that they poured here, the moisture that's traveling through the dirt is causing this this wall to collapse. And you can see in the back here, you got a vertical crack. So that's a tremendous amount of water pressure coming in on that back wall. So this is the way that they handled that situation, was they put in a sump pump. And that sump pump is basically an ejector system with a float. You see the wire right here. It has a float that's once the water actually fills up this little dugout area right here, the float causes the motor to turn on and eject whatever water might be in this little pit right here that's been dug. I suppose that's the best they could do, but it really should have been addressed from the exterior. Sometimes they put a drainage system on the outside to try to remedy this, but perhaps that wasn't totally available. So that's what we're dealing with in this particular instance. There are supports that are put in. So, you know, when we do have moisture and we have a water perhaps traveling through a basement area, being that the structure, again, is set to transfer the load to the foundation, we have some what we call masonry block piers. Piers and supports can be found in many, many homes, and specifically older ones. Because once moisture does actually enter into a closed-in area like a basement or a crawl space, it's a warm, dark space, moisture, perfect opportunity for mold growth. Moisture and wood is also a wonderful opportunity for termites to have their tunnels and to attack the structure. So that's what we'd be looking for. In this case, we're just showing some support here on the main beam running through the bottom of the home here. And they've put in some masonry supports because there's been some sagging taking place and they wanted to level this area out. Here we can see a situation where the pier actually has failed. If you look down here, you can see there's water down here, there's gravel. They've tried several different methods of stopping the water from coming in to the basement area, and it's been unsuccessful. So water has been traveling through here for some time, and eventually the soil gave way and the pier actually failed. So the next step after that, you know, we came to our poured concrete foundations, which is what's being done for the most part today on new construction. So if we're above ground and we're not doing slabs, we're doing poured concrete foundations. And the way it's done is, of course, you can see here that we have our forms in place, and then you can see the rebar that's actually sticking up here from the original pour. So the original pour would have been the foundation itself, and then the extension would have been to get that area above ground. In this particular case, what we're looking at is, I can see on the left side, which is the exterior of the foundation pour that's going to be taking place. So the actual wall here would not be 2x4s or aluminum structure. It wouldn't be masonry block either. It would be, again, a poured concrete foundation. So the concrete would go all the way up from the bottom all the way to above grade. You can see on the side here, they're already starting to put in some gravel and perhaps a drainage system there. But that rebar that's installed here is to hold the whole structure together. So once the forms are removed, it'll just be a poured concrete slab all the way through. And so this is still going to be a crawl space area. They've got the gravel down here, and I'll show you what transpires after that. Alrighty, so now we're looking at a totally poured concrete foundation. This area right here would probably be where the garage would be perhaps installed. And The rest of it is all, you can see it's pretty high, maybe 8 feet, 10 feet, which would be great for a finished basement at some point in the construction process. All righty, so now we're looking at a shorter crawl space, poured concrete foundation here, storage area. For guys like me doing inspections, this was lovely. You could stand up or even kind of just bent over slightly. You could easily walk through here, and it wouldn't be a knees and elbows crawl or slither through a very low crawl space. So this would be fun. And what we get to see here is not only the concrete structure, the way it's being done, but we see the main water supply line coming in from the street. And of course, up top, we can see all of our structures. So we're able to identify, floor joists, the actual plywood or oriented strand board for the subflooring. In some cases, there might even be insulation that we can report on. Also the water supply, etc. So all of that's available once we go up underneath the house. We have here a poured concrete foundation, and as much as folks say that something is perfect, there is really nothing out there that is totally perfect. And here we have a poured concrete foundation wall that is imperfect, and this is caused by a couple of different reasons. Perhaps during the original pour, you can see there's a little piece of metal here, which would have been from the form that was set. When they bring the truck and they have that big tank on the truck, it carries what they call 9 yards of concrete in it. That's the capacity of that cement truck when it arrives. So it's all pre-mixed cement, and then they take and they either pump it or they wheelbarrow it or they put it on that little slide that they have, and they pour it all in to the area between the actual forms, and then they run out of concrete. So they have to send the truck back to the plant to get more concrete to finish the pour. And the original concrete has already started to dry and to set up. So by the time the truck comes back in 2 hours or however far away it was, the settlement, the drying process has already started. It's actually more of an issue in the middle of winter when they would have added an additive called calcimine to the actual product in order to help it set more quickly, in order to stop it from freezing, or else in the middle of extreme heat in the summer where the curing process would already been started. So there's kind of a weak spot right there where the two pieces of the pour are actually joined. And sometimes it's just a simple matter of a minor settling, and there we have it. So we have a crack here. What we see on each side they used a vinyl type of patch here on the inside. If you look carefully, you can see bubbles that are noted right here, and we see this white stuff on the sides. The white stuff is actually called efflorescence. It's that moisture that is showing up on the inside of the pour, the reaction with the cement. And the little bubbles here are actually moisture bubbles that have come in through this crack that's been patched. So there's several different ways to patch the cracks. Obviously, the best way to do it, if you could, would be to excavate on the exterior. But sometimes when these cracks show up, it's really way further along the line, and we've looked at gardens and things being placed, and so we're dealing with we don't want to dig all that up. So you do it from the inside, and you could do it with an epoxy ejection. You can see here where they drill the holes and they put the plugs in there, and they put the chemical into there, and then it hardens up and stops it from from entering the water from entering there any further. So we just see a couple of different ways that it can be done right there. So when we do deal with the moisture, as we mentioned, termites are in there. They love to get in and eat up on the structure that we're looking at right here. There's a couple of pictures of damage that we have seen right there. So with the fact that we have wood rot or we have termite damage, we have perhaps the beams that settle. You can see here where these folks are actually measuring. They have what we call a temporary support that's in there, and now he's measuring for a permanent support that would be installed here. This is just a regular jack that can be adjusted up or down. And here we're going with a permanent support. They would have a proper little footing in here, a little foundation. And you can see there are plenty of them here. In this particular case, this is an older home. You can see by the age of the darkened wood here. And it was a brick foundation out there. So that was even prior to block, cement block or poured concrete. And so we have a stable support system in here where we actually have that footer, and we have the top of it secured to the beam as well. And this is going to be left just as is. The only comment that would have been made by an inspector at this point would have been perhaps the lack of a vapor barrier down below here. This is one of my favorites, a great advertisement for Rubbermaid. This was a home that had been renovated, and the shower had been, a shower pan had been deteriorated and collapsed. And so this is the way they supported what was underneath there. I thought it was a good chuckle and a great advertisement for Rubbermaid. So we find all kinds of weird stuff down there. We actually found one with a wall that was built out of batteries, old car batteries and things. The least they could have done in this particular case, if they were building with car batteries, is to have them the right side up, but these were all upside down. Just kind of the fun things that we would find when we're actually doing our inspections. It's amazing how folks think that inspectors would probably not go into a crawl space. At HomePro, we do. We have a goal of being able to touch all four corners of that crawl space and get to all the areas that are under bathrooms and kitchens where there are likely to be more chance of rot and problems there. But we do want to get to see the total foundation. We want to be able to get all around there. And that's what our goal is every day that we do get into them. Most of the time when you have a county or city inspector, they're not going to go into a crawl space. So it's really important if you have a new build to have a pre-drywall inspection or you know, have somebody like HomePro to go in there and have a look at the structure underneath before it's covered up. The county inspectors will look at a structure when it's open before the actual flooring goes down, the subfloor system, so they can see everything from above. They don't crawl spaces. In this particular case, there was an issue with going ahead and putting in some foam over the dirt in a foundation. And we're seeing not this particular application, but foam insulation has become a big thing now. We're seeing a lot of it in our attic spaces. And it's certainly, we're seeing it below the floor in some instances, in crawl spaces and in basements too. What we find is, and you know, there's always a pro and a con to something like this. In the case where we would have foam insulation blown, you know, installed into a subfloor area or even into an attic area between the rafters, is you cannot see the actual structure in the attic. So we cannot see if there's anything leaking there until a large stain shows up after, you know, it takes several months for of steady rain into an area that was leaking to see the stain in the attic. And in the basement area or the crawl space, if we're looking at trying to identify items in the plumbing or the heating and cooling or even the structure, and the foam has been installed, we can't see that either. So it is really a limitation in what we can and cannot see. So there we have, you know, it's kind of a look. We see our engineered floor joist here, and you can see the structure of the foundation. And this is the way the actual weight is distributed over to foundation section. So we're right at 29 minutes after. So I think we could stop and see if perhaps there are some questions that we might have at this point.
All I don't see any questions from the chat. Let me tell everybody what's coming up, and then we'll see if we get questions as they come up. So July, we have asked our CE teachers, who are me and Rael, our favorite classes. And so you have the subject matters that are most near and dear to our hearts on tap for July. So if you are heading out on vacation, you can take us with you and get some CE credit. Or if you are frustrated that traffic has come back as the world has opened up, the good news is that we still offer those virtually. And then I want to tease you with what's going to happen at the end of October. I'm super, super excited. I have my stats class coming. It is a CE class where we will, Rael and I will teach it together, and we will take the statistics of the last, I can't remember if we're doing 5,000 or 10,000 inspections, but thousands of inspections, and how frequently do the expensive items come up by price point of the home, and how and what are the most frequent things that do come up. So I think that will help give your buyers. I've been thinking about inspection lately and thinking about that what everybody wants is for the buyer to have confidence in the house. And I think that a better plan is to help the buyer have confidence in themselves as a homeowner. And so giving them some perspective on where this house sits in the risk umbrella can help them make really great decisions for themselves. And then they don't have to ask people like Rael and like you, should I buy this house? So that's what's coming up from Home Probe. I will look at the chat. I do not see any questions. So Rael, thank you so much.
We do have one question here from Marsha. Why is a vapor barrier necessary when there's no water or deterioration issues in the crawl space? For example, there's still sand in the crawl space after 4 inches of rain in a couple of hours. Thanks. So, okay. The bottom line is that, even though there might not be water traveling through the foundation on the interior, we do have the soil there. So the soil does emanate. It does allow whatever ground moisture that's in there to come up into that area of the crawl. So this one sounds like it's well protected, but the soil does have moisture, and if you go deep enough into it, you will have it. When we go into the crawl spaces and we do look at the actual structure, there might not be a lot of mold growth there, but there is a little bit of mildew. It's always there. You can kind of smell it when you go in. So that's why the moisture barrier is recommended to be there, Marsha. So you want to go ahead and in all cases when we go in, we will mention it. It's a minor fix. It's a couple of $100 at most to go ahead and put in that polyethylene. Just to lay it out, the big old barrier, and then you're protected. I hope that's, what's that?
That's a great question.
Yeah. Anybody else? And we're here. If not, you can always text us, info@homeprobe.com. We'll be happy to get back with you and answer anything that you have in your mind about what and how and why.
All right, everybody, make Rael and Home Probe your best friend. All right, go do some real estate, and we will see you in the next class. Thanks.
Bye, guys.